class, we are going to study some of the question bank questions of CAM profiles. These are the questions related to part A, which are critical thinking questions and also problem solving. Let us begin. It is the question related to the CAM profiles, to draw the profile of a CAM for a knife edge follower. So here it is. The oscillating follower is a knife edge follower. It is having a motion when the follower moves outwards through an angle or displacement of angular 20 degree during 120 degree of cam rotation, and the follower dwell for 50 degree and it returns to its original position, to initial position, during 90 degree of cam rotation. So it is the uniform velocity of motion during outstroke, and it is during ascent, and SHM, simple harmonic motion, during descent of the follower. And the axis of the follower is following the not offset, means the axis of the follower is passing through the axis of the camshaft. The axis of the follower is passing through the axis of the camshaft. That is the meaning here. It is not offset. Here moves outwards through an angular displacement, but there is missed here. It is not through 20 degrees. It is 50 millimeters during having a displacement of the follower. Having a displacement of 50 millimeter during outstroke, that is 120 degree, and it is the dwell remains the same for 50 degrees, and to returns its initial during the next is 90 degree of, that is the return stroke, and remaining is the dwell. So theta outstroke is 120 degree, and theta dwell next outstroke is 50 degree, and theta return stroke is 90 degrees, and the remaining, that is 360 minus 120 plus 50 plus 90. 360 minus 170 plus 90, 260, that means 100 degrees. So this 100 degrees are theta RD. So these are the return strokes. With this we have to draw, first we have to draw the displacement diagram. I am going to explain the procedure how to draw. But the follower is knife edge follower. It is the knife edge follower. How to draw the displacement diagram? Theta RD equal to 100 degrees. First, whenever we are drawing the displacement diagram, we have to find out what type of follower, and also during ascending what type of motion of the follower during ascent and descent. What is the ascent means? Rising. Descending means returning, falling down. These are the synonymic terminologies, like outstroke. During outstroke it rises, follower. That is called angle of rising or angle of ascent. Descending means angle of falling or angle of return stroke. So dwelling is the word is the same. So with this data we have to draw the displacement diagram. During ascending, the follower motion is uniform velocity. During descending, it is SHM, simple harmonic motion. So first to take a scale of on x-axis. So take a scale on x-axis. That scale equal to, assume that some 10 degree equal to 1 centimeters. So it is easy for you. So we have to draw this. Theta O becomes 12 centimeters. Theta OD 5 centimeters. Theta R equal to 9 centimeters. Theta RD 10 centimeters. With this length 120 centimeters, 12 centimeters, that is 120 degree, that is theta O. So on y-axis it is 50 millimeter. So with this is theta OD, this is theta R, and it is theta RD. So next step, the height, the axis y is 50 millimeters. Now divide this outstroke and return stroke with equal divisions. Divide the outstroke and return stroke portions with equal parts. So divide this 12 centimeters length into equal divisions of 6 equal divisions, even number of parts, so that each part is 2 centimeters width. Mark this 0, 1, 2, 3, 4, 5, 6. Similarly, return stroke also divide into equal divisions. Now, it is equal divisions, so join this point. This is suppose P and it is Q. From O to P, straight join. That is a uniform velocity displacement diagram. Whereas for simple harmonic motion, during outstroke it is a simple harmonic motion. Then what to do during descending? We have to join the center point, draw a semicircle, because when you point P, it we having a circular uniform motion. The projection of with having a speed of uniform velocity of omega p, that is uniform angular velocity omega p. When the point P is having a uniform angular velocity rotating in circular motion, rotatory motion, the projection of point P on either on y-axis or x-axis gives the motion of simple harmonic motion. So when the point P is rotating circular direction, the projection of point P on the vertical y-axis or x-axis, the motion of that particular P is the simple harmonic motion. So we have to divide the semicircle into equal divisions and project, suppose 0, 1, 2, 3, 4, 5, 6. This 1 you project on one line. Next 2 project is on second line, 3. Similarly 4 and 5 and 6. That's why it is 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, 0 dash. This curve indicates the simple harmonic motion curve. So it is the displacement diagram. Displacement diagram is the diagram of angle of rotation of the cam versus the lift of the follower, is known as the displacement diagram. This is the curve. Okay. This curve indicates the displacement diagram or displacement during the particular angle of rotation of the cam. The lift of the follower is having uniform velocity during ascent, and during descent it is a simple harmonic motion. The shape of the curve looks like this, which is shown in blue color. This is the displacement diagram. What is the significance of displacement diagram? Why we are going for these divisions? This 120 degree, each having 120 means each is 20 degrees. So that's 20 degrees means at 0 and 1. At 1 means cam is rotated 20 degrees. Next to 20. When it is at a 20 degree initial, it is at point A. The follower is vertically moving. It is moved from 1 to A. Next, from from 2 to B, it moves. From again to the level of C, D, E, finally P. So at the end of 120 degrees rotation, the maximum displacement of the follower takes place. That is known as the lift of the follower. Here the lift of the follower is 50 millimeters. Alright. Now here, similarly during descending, the return stroke, the angle of return stroke is 90 degrees. The 90 degrees divided into 6 equal parts means again next to 90 degree 15 degrees turn, each 15 degrees of rotation, the follower moves down, the follower comes down, descending takes place from Q to E dash, next to D dash, C dash, B dash, A dash. Like that it comes back to the position. This is the manner during the angle of rotation. What is the angle of dwell? The dwell angle is 50 degree here next to the outstroke, and there is one more RD, that is 110 degrees after the return stroke. What will happen here? It happens, the position is that it remains dwell. Why it happens takes place? So the dwell is the position where there is no neither ascending nor descending of the follower takes place. Okay, that is the meaning of this. This is the displacement diagram. Next, we have to draw the cam profile. So, how to draw the cam profile? First, draw the minimum radius of the cam was not given. The minimum radius of the cam is assumed as 25 millimeters radius. That is the minimum radius of the cam. You can assume 30 millimeter if it is not given. If it is given, then okay. So the minimum radius of the cam is considered is here, that is 30 millimeters or 25 millimeter, choice here, but you have to write down assumed the minimum radius of the cam equal to 30 millimeters. Draw 30 millimeters radius, draw the base circle with the 30 millimeters radius of the cam. Yes, this is the axis of the follower. This is a freehand sketch. The axis of the follower is passing through the axis of the shaft. This is the axis of the follower. Now this is the reference axis with this. What is the outstroke angle? The theta outstroke is 120 degrees. With this, draw a line 120 degrees. That is outstroke. The next is 50 degree, 120 plus 50, 170. Next to outstroke. Next one, return stroke is 90. The remaining angle is theta RD, that is 100 degrees. Now, divide the angular displacement, that is outstroke angle 120 degree, into even number of parts. The number of parts are which we use here 6 equal parts. That is what we have divided in displacement diagram also. Same number you have to divide here, this angular 120 degree, into 6 equal parts. So those parts should pass through the center of the base circle. When the knife edge follower touching the surface of the base circle, that point is known as a tracing point. Similarly, the outstroke should be divided into 6 parts radially, the angular. Yes. Now, these are the tracing points when there is no angle of rotation. And now we have to take from these points to the motion of the follower. This is the 0. It is 1, 2, 3, 4, 5, 6. Similarly, 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0. Now these are the points, or the point. From these points we have to mark the displacement of the follower but a particular rotation. So it is 0. Next, when cam is rotating to 1, that is 20 degrees. That 1, what is the displacement is A. So 1 to A, you measure 1 to A, 1 to A. Next, similarly, you follow the method. Next, 2 to B. With the point 2 at that position angle of rotation, the follower is at this position B. And the cam is rotating next 30 degrees, that is next division 30, that means 20, that is 60 degrees. It goes to C. Take it distance. The length is that from 3 to C, 4 to D, 5 to E, 6 to P. So 4 to D, 5 to E, 6 to D. Similarly, on the return stroke, it is 6-2. Where is the length here? It is 6- to Q and 5- to E dash. Not from this vertical position, should not take from the top. We have to take from bottom only. So 6- to Q, this is the 6-, approximately Q. Here it is P. 5-, where is the 5-? 5- to E dash. This is the 5- is the point. Mark it here, E dash. 4- to D dash. 3- to, again, 3- to C dash. 2- to B dash. 1- to A dash. It is 0. So passing, now join all these points. Then we can observe the cam profile, the shape of a cam. That is known as a cam profile. Now join this O smooth curve. So this curve is the shape of a cam profile. The blue circle is the base circle. The contact point follower and the base circle is the tracing point. So these are the points. Now at point A is the tracing point for the follower for the next 20 degree. Next consecutive 20 degrees it is at a B, C, D, E, P. Similar return stroke. It is 100 degrees of dwell. So the dwell at 100 degrees, there is no, the follower neither moves upwards nor downwards. So this is the procedure for the question. This is the solution which we answered. And one more thing, while drawing, very important thing is that we have to draw base circle, radial lines and follower. All these points should be light in color with pencil, whereas the cam profile should be dark. It should be dark because the main. So this is the cam profile. Okay, the type of follower is knife edge follower. During ascending, the follower is having uniform velocity, and descending it is simple harmonic motion. So this is the solution. The next question, next go to, this is the same, but the point is that here Here it is passing through offset. It is also not offset, but the point is that the follower is a roller follower. It is the roller follower. Draw the profile of a cam with oscillating roller follower. It is roller follower and it is having moving outwards through 50 millimeters during 120 degrees of cam rotation. Dwell 50 degrees, returns to its initial position. This is 90 degrees of cam rotation, that is return stroke. It is having same uniform velocity during ascent and a simple harmonic motion during descent. The axis of the follower is not offset, that means it is following through the axis of the camshaft. So we have to follow because the data is same, but in the case of knife edge follower, here it is roller follower. So how to draw the roller follower? So same displacement diagram, whatever follower may be, even though it may be flat faced follower also, because the diagram related to the type of motion of the follower. It is not a type of follower. It is what type of motion. The type of motion of the follower, here it is uniform velocity during ascent and simple harmonic motion during descent. So we have to follow the same displacement diagram, but the cam profile how to draw with that displacement diagram. The data is same, so we have to follow same displacement diagram. You redraw, and let us follow how to begin with cam profile with this roller follower. Now here they did not give you one thing, the minimum radius of the cam. Here it is, the minimum radius of the cam equal to 30 millimeters, assume, and radius of the roller, we have to assume it. If it is not given, if it is given, 10 millimeters radius. Now with that start, first draw the base circle, draw with the given dimension, that is 30 millimeters. This is the axis. The axis of the follower is passing through the axis of the shaft. Now from this point, take the radius of the follower, that is 10 millimeter, mark the center of the follower. Draw the roller circle. This center is known as the tracing point. Now this is the reference. With this reference, draw another circle passing through the center of the base circle, from the center of the base circle to the tracing point. That circle is known as a prime circle. Divide this prime, this is the reference point. With this mark the outstroke, return stroke, and theta OD and theta RD. Here theta OD is 120 degrees and theta D, that is 50 degrees theta OD, next 90 degrees, and remaining is 100 degrees. Alright. Divide this prime circle into equal divisions, which is even number of parts. Those parts are 6. Similarly, outstroke also. Here we are dividing the prime circle circumference. Now take from displacement, mark it. These are the points O, 1, 2, 3, 4, 5, 6. This is 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, 0 dash. Now from 1, take the distance, vertical distance from displacement diagram, from the partition of the outstroke portion. From 1 to A, mark this A. Similarly 2 to B, 3 to C. This is the diagram displacement. 3 to C, 4 to D, distance from point 4 to D, mark it. This is the point marking from point 4 to, this is the distance. Next 5 to E, 6 to F, or in that mentioned P. Next 6 dash to, that is the Q. Next 5 dash to E dash, 4 dash to D dash, 3 dash to C dash, 2 dash to B dash, 1 dash to A dash, and so on. These are the centers of roller. So now we have to draw the roller. A is the center, draw a roller. These rollers may intersect each other. It doesn't matter. No problem. And finally, point O comes. This is the center, touches. Now passing through the surfaces of all rollers, if you draw a curve, that curve represents the profile of a cam. That is the cam profile. Now, here, now I am passing through that. Okay, this is the way. This is the cam profile. When the follower is roller follower, so this is the case of when the axis of the follower is passing through the axis of the camshaft. So once again, here in this, the base circle is different from prime circle. This is the prime circle, and here it is, the base circle is, this is the base circle. In the case of knife edge follower, the base circle and prime circle both are same. Here it is, the prime circle is larger than the base circle, and the radius of the prime circle equal to radius of base circle plus the radius of the roller. So, and these are the tracing points. So the tracing point, prime circle, what is the prime circle? Is the circle which is drawn from the center of the base circle to the tracing point, passing through the tracing point. That circle is known as prime circle. Here the follower is the roller follower. The radius of the follower is 10 millimeters. So in the case of knife edge follower, the tracing point is same. The contacting point of base circle and prime circle both are same, because we have to draw touching the contact surfaces, whereas in the case of roller follower, will not passing to the center of the rollers. The curve passes through the surfaces, contact surfaces, because the roller touches the surface of the cam. That's passing, the curve passing through the surfaces of all the rollers. That curve is the cam profile here. And one more thing is that very important here. If this is the case, the axis of the follower is passing through the axis of the camshaft. And one more thing, dwell, where the dwell, that it is the radius is remains same. While practically drawing from point O2 up to F circles, we have to use manually, how to draw. But here the radius between the dwell position, it is a constant radius. So you can use compass and complete this curve. The contacting surface for both contact, the length, the radius remains the same. So that's why you can use the instrument, the compass. After that again it begins touching the smooth surface, because here the radius is variable from O2 up to F, O to P. So rollers are there. Those rollers centers are, it is variable radius. But at a dwell position is a constant radius. We can see the constant at a P contact is the same Q roller contact, the same remains same because it's the dwell position. The dwell is the angle where the follower neither is having ascending motion nor descending motion. That means it doesn't move. That is the meaning. So in comparison to knife edge follower is the point contact. Roller follower also is point contact with the surface of the cam. That's why this follower comes under the category of higher pace. So for higher pace, the coefficient of friction is low in comparison to lower pace. What is the lower pace? The definition of the lower pace is that the contact between two elements is either area of contact or surface contact. Then those elements, that means pair comes under the those pairs comes under the category of lower pace. For lower pace, it is the area contact or surface contact. That's why the coefficient of friction is high. So for smooth running motion, for transmitting the purpose, these higher contacts are used. So here the lower pair, here follower, what is the exact, the follower meaning is that here roller follower, here these followers are nothing but valves in the case of internal combustion engines. For each cam in touch with the only one valve. So this cam purpose is that valves closing and opening. It controls the valve positions. For operating the valves, this cam profiles are used. So very important. One more thing, angle is that there is a pressure angle. What is the pressure angle? We studied that. Pressure angle is the angle between the motion of the follower to the normal to the pitch curve. So here, if the pressure angle is maximum, the follower jamming takes place. The follower jams in its bearings. So the pressure angle is very important in designing the cams. If the pressure angle just should be optimum, neither low nor high. The optimum value of the pressure angle is important for smooth running of the follower or opening and closing of the valves, controlling the valve motion. When valves are under smooth functioning, there is during suction stroke, it is valves are connected to next cylinder, and cylinder inside the cylinder there will be piston. This piston controlling motion. So it is everything is interconnected. The controlling of the valves is dependent on the angle of rotation of the cam. In that again, angle of rotation of the cam means angle of ascent, angle of dwell during ascent, and angle of return, and dwell during return. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.